Hello, statistics student. This video is for chapter 6.1, part 2, about finding probability of z-score or z normal. And we are into using inverse normal calculator to find z that correspond to percentile. So continue with example 3 is finding p 91. So this notation means 91st percentile. So maybe there is a need to tell a particular z-score is at the 91st percentiles, and you want to find that particular value. So remember, percentile is this particular value is at or larger than 91% of data. So assume that this is about 2-3%. So I would say this is 9%. So this is 90. All these are 91%. So that corresponds to having 90% or 0.91 area on the left of this z. This z is actually the 91st percentile. So we always use below when we do percentile. So it's 0.91. The area is 0.91. So we would use this one, area 0.91, but it's on the below side. And then, yeah, so this is the value. You can recalculate 1.341. So you would say if z is less than, for all the z that's less than 1.341, there's 91% of it. So the cutoff is 1.341. Or the cutoff for the 91st percentile. What about 15 percentile? It must be a very low number, right? So probably here, just an estimate. So this is 15%, right? So 0.15 area. So again, we use below. Whenever we calculate percentile, we use below. Specify not 0.91. So there's a typo here. I should change it in the notes. So it is 0.15, is it? Yes, 0.15. And so we calculate 0.15. So the area should be 0.15, but it's still below. And I do recalculate, so I would negative 1.036. So negative 1.036. So you would say probability of z is less than negative 1.036 is 15%. 15% of the z value are less than negative 1.036. So it's one more concept. The last concept is finding a z that corresponds to a critical value. So the term critical value in statistics means it's like the threshold. Kind of like a borderline. So whether you can be accepted, like in the college application, you say, what's the threshold? Oh, your GPA have to be above 2 or above 3.0 to be accepted. So that's kind of the threshold. So you could be 2.999, very close to, but if you're not over it, you cannot. So this critical value is kind of like that fence, the cutoff, right? So we call it a Z alpha. Why? Because this cutoff is related to what is unlikely, significant value. That means it's a cutoff for if it is below that, those Z value are very significant, means very unlikely, rare and unlikely. And if you are higher than those value, oh no, if you're lower than those value, because usually the Z alpha values are at the end, right? So this is a negative Z alpha. They are the really low, that's very rare. You know that in the bell curve, anything that is 2 to 3 or about over 3 is so rare. So there must be a cutoff. So in the past, we used a significant level. Alpha is called a significant level. It's 0.05. The default is 0.05. So that means if your probability of showing up is 0.05, that is counted as significant. Now, because we can say probability of a value, so it would be a range of value from that number on. on the right side or left side is the level. By default, it's 0.05, but you can assign your significant level. You can say, well, I don't want 0.05 to be rare. I want 0.01 to be very rare. And I want, or you can say 10% is rare enough. So you can adjust your significant level. And then we use this Greek letter alpha. I think everybody knows alpha is like A, right? So you write it as if you're writing a 2. So very similar to writing a 2. So it is alpha like that. And alpha is called significant level. It tells you what a value is, or not value, but what percentage is classified as unlikely. And by default, it's 0.05. So Z with a small alpha over alpha at here means the critical value that cut off likely and unlikely. Okay. So if I want Z alpha, that means on the right side, it is always the positive one, right? Once you find the positive one, you can find the negative by attaching the negative sign. So significant low critical value is negative Z alpha. Significant high values are Z alpha, where the right area, total area, is 0.05. So we are to find Z. We know the area is alpha. Okay, alpha is the unlikely event. So we use inverse normal, where the specified area is right and is always above. You click above for critical value. Okay, so first example, if I assume alpha is not 0.05 anymore, but it's 0.02, what is the critical value? So we can actually do it 0.02. The area is always above because it's always on the high side, right tail. So it's 2.054. So that means 2.054. 2.054. So that means 2 point something. If you're at 2 point something, if you're over it, these are very rare. If this Z show up, that means it is a surprising. 1 point something, 1.9, even 2 itself is not rare. It is considered not significant. It's considered that can happen by chance. So how can you tell your Z? You look at your data value, subtract by X bar over, subtract by mu over sigma. That would be your Z. So 2.054. What about if I set my alpha to be 0.06? What is the critical value of 0.06? 0.06 will be larger, right? I think it's still around 1 and 2. So you want to do this Z alpha also with the right area of 0.06. So I just need to change this 0.06. Oh, and you recalculate 1.555. So any Z value that is higher than 1.555, according to a significant level of 0.06, is counted as rare. Okay, so that's the end of 6.1.